again. You're back. Good to see you back. Well, last time we talked about the Big Bang and my theories on how the universe actually is. And I said, hey, why don't we delve into quantum physics theory? Now, as you know, quantum physics theory, apart from covering the Big Bang or the Big Bangs, also tackles things such as time travel, parallel universes, dimensional overlaps. Well, let's do a quick look at those. Come to the board, will you? Let's start with time travel. Now, the old view of time was Big Bang, there's time, linear. You have a start, and you will have an end. Know what I say to this? I use the old term, poppycock! This is human thinking, because we have a start and an end. All the universe must have a start and an end. Forget that stuff. Okay, you have to think bigger than that. There's been some theories over the years that the universe is like this. Start, it's a circle, boom, it comes back. You know, when I was 10, I thought that made sense. When I was 10. I'm not 10 anymore. So this kind of thing doesn't make sense. What you have to look at then is, well, where did the universe start? Most people, Big Bang, God, Allah, who cares? If you just take for the fact the universe exists, period, and you don't have to worry about, oh, when did it start, then you can actually start looking at different things. Now, as we know, in space, everything moves. So here's wonderful planet Earth. Okay, and we're 2011. Now, if you go back, say to the 1965, planet Earth might have been here. So in theory, time travel, I want to go back in time here. Well, you'd have to calculate, because it is possible, folks. If you use two things you can do. You need a tachyon drive, you need a particle that can accelerate you beyond the speed of light, and you need to be able to survive that travel. And you also need to calculate where you are in space. As you can tell, it's not an easy formula. Where you want to go to in space. In other words, you have to calculate where the Earth was in 1965. But to do that calculation as well, you also have to calculate where the solar system was in 1965. And so forth. So yes, time travel in theory is possible. Can you imagine the amount of calculations you have to do? Because you have to calculate where you are, where our solar system is right now. You have to calculate where the universe is sort of positioned now. And then do the math and go, okay, where was it back then? Because if you had a tachyon particle, you could, with all these calculations done, go, okay, I'm going to go faster than light. Whoosh! I'm going to get there. The odds of you figuring that out as a human being, pretty rare. Now, as for the other type of time travel, the kind you see in the movies, okay, here's planet Earth, 2011. I'm going to set my machine to go to planet Earth, 1965. I'm right here. I'm going to go to 1965. Now, with all those calculations, what's going to happen? Yeah, you might be able to shift the vibrational walls of the fabric of time, but you're going to know by being in empty space. So you have to know all these calculations. So time travel in movies, for the most part, not really practical. Okay, which brings us to the other things. Well, what about in quantum parallels and so forth? Now you're thinking a bit out of human terms. Okay, here's our Earth. And as we know, we're not really matter. We're just vibrating atoms. We're energy that vibrates. So our Earth vibrates, we'll say Earth E1, Earth 1, vibrational rate 1. Now, what if there was an Earth, same space and different quantum field, that operates at E2? How about one at E3? Same Earth, same roughly location in space, however, all different vibrational frequencies. Now, time travel in this sense, you can go from I'm going to tweak the vibrational tones. Hey, I'm actually going sideways in space-time. I'm not actually going anywhere, really, but I'm changing my vibrational frequencies just enough that I'm shifting to a parallel where it's 1965. See, that's more possible, folks. And the funny thing is this. In this type of situation, this all started at the same time, just things evolved differently. So, for example, our universe here, 2011, created the same time as this vibrational parallel, but things took a slower pace there, 1965. Now, there is a catch to this. Try coming back. Unless you can exactly record what your vibrational frequency is, you might actually end up by doing this. Looks the same, feels the same, but it might be something different. It kind of blows your mind to think that, hey, this might happen. This actually is more mathematically possible than anything else. Well, I think you've had enough of quantum physics for today. This is Mad Montreal Man. You got some more requests? Give them a shout. Maybe we'll do history one of these days. Keep thinking outside the human box.